Well, I will give some words about the metal ion and EDTA complex. Okay? As I said, other forms of EDTA than this fully deprotonate form can have a complex with metal ions. Okay, what does that mean? Here is an example. Okay, here is a metal ion, and let's see. This is what not fully deprotonated, but it has two protons. Yeah, two dissociable protons in its structure, and although the final complex the form takes this form, okay, but this one also uh, can involve in complexation, okay, here. So, but this metal ions now replace these protons, all the protons, okay. As a result, the protons are dissociate into the solution, so solution becomes more acidic, okay. Not only this form, but also H3 Y minus, and then after reaction with these metal ions, and then three protons are generated, okay, like that. So don't worry about um, the form EDT forms. Virtually any forms of EDT can have complex with metal ions. So, but how do we treat that in the case at a lower pH? Okay, and then we can have a way to systematically treat the case. Okay, I will give you a lecture in shortly. Okay, the conditional formation constant, you know, can do that. Okay, here metal ions and protons compete for this EDTA. Okay, and metal ions always win. Okay, here metal ions now kick out the protons. Okay? The final form of a complex is all the time, oh, this is large y, okay, my n minus 4, okay. Um, don't be confused. That's what I was confused when I was like you a long time ago. Okay, and then this table shows the log kf value for this equation. Okay, this is called the formation constant. Okay, and for lithium, log kf is 2.95, almost 3. So kf is what? Almost 1,000. Okay, and sodium ion kf is 10 to 1.86. Okay, like that, and potassium ion is even smaller. So that means that although this EDTA can complex with the metal ions, but these alkaline metals, right? The formation constant is rather small, so EDTA, is not readily applicable to the determination of alkaline metal concentrations. Okay, but when this charge increases, like beryllium, divalent beryllium, magnesium 2 plus, calcium 2 plus, yeah, look at that. The formation constant, suddenly increases, okay, more than around 10 or more than 10, okay, for strontium ion, it is Kf is 10 to 8.72, like that, okay. And for the trivalent metal ions, even, you know, the increased even much higher increased, okay, to 23.1, like that, okay. So and you see the this values, and then you can conclude that usually kf value is really big, okay, very high, yeah, except several monovalent alkaline atoms, okay. Yeah. So that's why EDTA, determination of metal ions are so widely used. Okay. Okay. Let's take a closer look at the EDTA complexes. Okay. Here, this formation constant. It is also said a stability complex. Okay, a stability constant. In many complexes, EDTA forms six coordinate species because EDTA is hexadentate, the ligand. Okay, that's why in most cases, in many cases, EDTA forms six coordinate species. Okay? With considerable strain in chelate rings. Okay, you see, to make the six uh, what to make a six coordinate species, the EDT structure should be twisted. Okay, so there will be a sometimes a considerable strain in chelate rings. Okay, however, the strain is relieved with the oxygen is drawn back toward the end. Here, where is the oxygen? Let me say this is oxygen. Oxygen is uh, drawn back toward nitrogen, and then the strain is a little bit released. Okay, and here, this oxygen is uh, uh, this oxygen. This is nitrogen atom, and the oxygen atom is you know the moved toward nitrogen. Okay, and this one here uh, opens up is a space. Okay, so this open space, one water molecule can bind to the metal ion. Okay, so in this case, let me see, in ion complex with EDTA, actually one water molecule binds to the this metal ion. So actually this is what, not hexa, this is hepta, hepta coordination compound. Okay, yeah, for this one, the iron magnesium. Okay, so such a distortion opens up the seventh coordination position here. Okay, for these ions. Okay, ferrous iron, magnesium, calcium, cobalt, manganese, yeah, like that. Okay, but some species also that is, so some of them form six coordinate complex. And but very interestingly, this calcium ion, orbium, and ytterbium, zirconium ions have eight coordinate compound. Okay, here, and in the from the I think one more water molecule now binds to these ions, so they form not hexa, not hepta, but octa coordination compound. Okay, large metal ion, it contains eight ligands. Okay, not six nor seven. Okay, yeah, large metal ion, more ligand atoms. Okay,